So today, the first 15 minutes, I'm going to have you take this formative completely on your own. Don't start it yet. Then once that's done, you might not have time to quite finish, but I'm going to, at quarter after, I'm just going to stop you and we're going to go grade it because we're nearing a test. So I don't want to go through it with you. You should be able to tackle them on your own. There were 3 formatives I didn't give you yet. I took the hardest parts of each one. The other stuff, I'm like, everyone's going to get this right. So it should seem, it's the hardest of the ones that were on 3 of them, if that makes sense. Then you're going to start our first test review. I'll pass that out. There's a key to it right here. Again, if we copy those keys, it's deadly. But there's some extra stuff on this slide. Is everybody listening? I see people starting. Don't yet. It's okay. There's an extra test review. That's just a video that I made, but a couple years ago. That's not extra credit or anything. It's just if this chapter you've been what? And then there's actually, and I'll give test points for this one. There's a group of 3 people who work in the upper tier of College Board who work together with Texas Instruments. Yes, that's right. TI Instruments. They work with them and make these videos, and they started doing it for calculus this year. So they take specific topics and they spend an hour giving the deets of it, but they are on the upper, like one of the guys, his name's Steve, is the actual what do they call him? Chief reader of the calculus exam. So there's all these tiers. I don't know if you know how it works, but there's a chief reader. And then there's the people who write the questions. They're the people who write the solutions to the questions. Then you have question leaders, and it filters all the way down. Then there's table leaders, and then there's actually the people who grade it, which is where I was. So actually it seems like I was on the bottom of that whole tier. The guy at the very top of it, he's in charge of the exam itself, is the guy who does these. And so they're really good. It's a YouTube video, so you do it on a separate sheet of paper, and just to make sure, because they lay out the answer before they start talking. So it is plausible that you could just write it all down and not actually watch the video. So put some quotes in there that they're saying so I know you actually listen to it. Does that make sense? Because it'd be really easy to cheat your way through that. I wouldn't think you would at this level, but it's good. They're boring, but they're good. Like they know what they're talking about. So I would just need that by the test day. So I've linked it on several slides. So then tomorrow we're going to continue with our test review. You're either going to be done with number 1 and start number 2. You're going to be somewhere in here. And then Friday's up for debate. It depends on how well you use the time today and tomorrow. So, because I'm going to give you the whole day tomorrow, today after the formative, to just work on reviewing. If I'm seeing people not doing that while you're doing this slide on Friday, I'm gone Friday. And this is what was originally scheduled. But review 2 was kind of long. So I was like, I could just give another day to review it. Does that make sense? So on Friday, one of these 2 will be sitting here. I won't be here. So you either continue with your review, and if that's done, you could go do the extra credit. Or if we're not using that time, because I told you we're kind of pressed for time a little bit, but I kind of want to give you another review day. But if you're not using it or people are done, I'll hop to this one. Does that make sense? All right, so go ahead, take 15 minutes. I'm going to pause this. All right, you should have a healthy chunk of it done. Maybe not quite finished, but I do want to get you started on the review. So I'm going to just kind of have you score yours, and mainly the details of this, because at this point you should be pretty good at most of these, and this is kind of to save you little points off. So when we're working with our particle motion, remember it goes, position, velocity, acceleration when we take derivatives. So when this is a question about velocity and you're given velocity, you just need to plug it into that function. Can you guys tell me what you've got so I don't have to do arithmetic? It'll slow us down. What'd you get? 41? Okay. So it looks like we should have a 41. It didn't ask for labels, but if it did, this would be in meters per second. So you wouldn't have lost a point if this was the prompt because it didn't say for units, but if it does, then it's a point. Then I added on there is the particle moving left or right. If you just say right, you don't get any of the points. Correct? Because that's 50-50 guess. You have to say because V of 3, correct, is what? Positive. You could even just put it right there as just a little notation. But moving right, and somewhere you have to say, if you say because it is positive, you can't use a pronoun. So you either have your V laid out or say the velocity is positive. All right, so that's just a detail. No pronouns. No what? Pronouns. Don't say it is moving to the right or it is positive or they have the same sign. Really avoid those as much as possible. Then it says find the average acceleration. So you gotta be a little careful. Instantaneous is at a specific spot. So if it said find the acceleration at 2, I'd have to take the derivative, plug in a 2, and I would label it meters per second what? Squared. Let that label help you out. Because average acceleration is over a period of time. Agreed? And this period of time is from 0 to 2. So you would say, well, 2 minus 0 would be on the denominator. There is 1 of your seconds. On the top, you need to actually understand that acceleration is change in velocity over time. Does that make sense? And what is velocity labeled in, by the way? Meters what? Per second. So you would see that. A lot of kids will do like something with the acceleration when it says average. It's not. It's change in velocity over change in time. So you should have plugged a 2 into the velocity and a 0 into the velocity. That word average is always over in an interval. The interval is always that. So if you did a of 2 minus a of 0, did anyone do that? If you did that, you found actually what's called average jerk. All right? And it would have been labeled in meters per second cubed. Jerk is what comes after acceleration. That makes sense, right? When you jerk in a car, you change the acceleration really fast. But be careful with that. Let the labels help you. Because if you did acceleration on the top, you would have had meters per second squared and then seconds again on the bottom. It's never a numeric average. You never add them up and divide by 2. All right? So just know that. I'm not sure what that equals. I'm not going to do the arithmetic on it just to save us some work time, but there it is. The actual acceleration at time t, I would need to see an a of t model. Can you tell me what the derivative of that was? Because I lost it. Do you have it right there? 6t squared what? Thank you. Minus 2t. You would then have to plug a 3 in. What did you get when you plugged the 3 in? 48. And it did say to label, but if it did, again, it would be the derivative of velocity, meters per second, and then per second again. All right? The next one up says find the speed of the object each time the acceleration is equal to 4. So I would have to take my a of t and say, well, I need to set it equal to 4. That's how it starts. Each time acceleration equals 4. You guys told me it was 6t squared minus 2t equals 4, right? I'm looking for the t's that will give me a 4. And I told you if you don't have a calculator, it'll always what? Factor nicely. So get it equal to 0, right? Factor out a 2. So I'm just showing some work here. I'd have a 3t squared minus t minus 2, correct? Are we good so far? Can you tell me what that factored into 3t and a t? It looks like it would be a minus 1 plus 2. Are we good? I'm kind of working fast here. But it says find the speed of the object each time the acceleration is equal to 4. Negative 2/3 you're going to discard. Why? I've been saying don't give me negative times in particle motion. It doesn't really make sense. T equals 1 is the only time when the acceleration is equal to 4. Speed. What is speed? Is it about position, velocity, or acceleration? It is the velocity, but it's one little more piece to it. Absolute value of velocity. So somebody who did that correctly and put the 1 into v, and then took the absolute value, what'd you get? What do we get? I can't hear. 3. And you're nodding, Nora? So 3, if I plug the 1 in up there, I'm not seeing a ton of people nodding. Not that I don't trust you, but when I put a 1 in here, 2 minus, I'm not getting 2 minus 1 is, oh, but I got negative 3. It's the absolute value. You are correct. Sorry. I'm getting a negative. It said speed, so we are good. That would be 3. It would have been absolute value of the negative 3. It didn't ask for labels, but Luke gave it to us, so let's put it on there. Meters per second. Speed speed increasing or decreasing, that is not about velocity being positive or negative. That just tells you if you're going forward or backward, correct? It's about both of them. So you need to tell me what v of 1 is. Don't do it in your head. They have to be actual numbers. Otherwise, you could sort of, the reasoning behind that, you need to put a 1 into both and declare what they are numerically. Some kids might know that it's increasing if the signs are the same, decreasing when the signs are negative, but not know how to do it. So you could just, again, it's back to a 50-50 guess if you don't give some work with it. What was v of 1? We just did it, right? -3? What was a of 1? 4. Okay, so now when it says justify your answer, you have to actually say decreasing, correct? If that's all you do, you'll get the 1 point, not the 2. Decreasing because v of 1 and a of 1 are what? Thank you, opposite signs. Opposite signs. Perfect. Excellent. Was there another one on our particle motion? Nope. So on to the next page. There could have been more questions, but we practiced that enough. We've got the cone thing again. Let's see. You're my first hour. I don't know if this is normal cone or funky cone. But it says we've got water. It's 8 centimeters tall. So that's the cone itself. And then it gives me the radius. Be careful if you're ever given the diameter. Whenever it says the dimensions of the cone, then what are we doing? Filling it with water? All right. So we're filling it with water. I'm looking for there it is. Let's put a water level in there. I'll do it in blue right here. That water level has a height and a radius, correct? And I've always said if you're given the dimensions of the vesicle itself, write down how R and H are related. So over on the side, I'm going to write H equals 2R. I might need it. I'm also going to write R equals what? H over 2. I might and most likely will need those. So do it right off the bat. Then what does it say? It says it's poured into the cup at a rate of, so that's going to be a positive. So I'm going to write dV dt is equal to a positive 3. Then it asks me how fast the water level is rising. That would be my H changing over time. The instant when H is 4. That is not a weird one. That's not level 5. This is straight up regular old cone problem. Would you agree? Mm-hmm. Right, there's nothing weird I need to do with this one. It sets, write the formula down. 1/3 pi r squared h. Go look at this. Don't take the derivative right now, right? I would if I had stuff about dr, dt, and r, but this is all about h. So I'm going to keep the 1/3. I'm going to keep the pi. I'm going to replace r. I'm going to keep the h. So my r is h over 2. How many of you did that? All right? That's what we always do unless it's, sometimes you need the product rule, but on this one we don't. So let's go write that out. We have pi over 12 h cubed for my v, right? What's up next? Just to kind of, regardless of what kind of related rate you're doing, they're all similar. Get a picture. Take the derivative now. Yeah, so with respect to time, and so I have 3 pi 12, so pi fourths h squared, and then don't forget the what? dh dt. Excellent. At this point, you go plug stuff in. If there's 2 unknowns, it means there's a way to find one of them. We're supposed to be finding dh dt. We know that the h is going to be a 4, and they gave us the dv dt. So I'm not going to go through the arithmetic of that, because right now it's just arithmetic, right? You're going to plug the 3 on the left and a 4 in for h. Let's leave it in terms of pi. Can somebody be brave enough to give me an answer? What'd you get, Audrey? 3 over 4 pi? Lots of nods on that, so I'm going to take it. If you didn't, you can ask me during the work time, but that would be 3 over 4 pi. Why would you most likely maybe lose a point or a half a point on this? Yeah. I do. All right. These always need a label. And it's the height that's changing, and this was measured in centimeters. Okay. So this would be, the height would be centimeters, and our time unit is seconds. All right. The next one. Have we ever done a hemisphere? Have we ever done the surface area of a hemisphere? No. Does it change your process? No. So don't let it freak you out. Ah, never had this one before. You always have that. You know my tests are never, every one is like exactly the ones you had on the review. That would be lovely, right? And you guys are hard workers, so you'd probably all have A's then. Because you make sure you do all the ones on the review, right? And I give you a test, and number one's just like number two is just like number two. That's not bad. But that's not how the AP test is. You know what I mean? You have no clue what they're going to throw at you. Will they throw you related rates? Yes. Might it be a cone? Maybe. Might it be a hemisphere? I don't know. It's something though, right? So let's go take a look at this one. Never worked with the surface area of water in a hemisphere before, but I guess I am now. They gave me the formula, which is nice. Alright, so there's my formula. My area is dependent upon the height. The surface area is a function of the height of the water. Got it. And then it says, when h equals 3, the depth of the water, which would be h. So I've got the h dt. It's decreasing, right? So watch that, negative 0.5. Let's hope they say when h equals and not something I have to mess with. When am I stopping this? Am I missing it? Oh, why did I? That's nice. Now it's not a level 5 problem. Correct? Like if that said when r was something or when the volume is something, I'd be, oh crap, I gotta go figure out what h is. Right? But I'm ready to start. Start doing what? Taking the derivative. What am I looking for in this problem? Why did I write? When h is 3, the depth. Oh, dA dt. Yeah, okay. At that instant, what rate is the area? So I'm looking for dA dt at this instant. All right, so let's go see if we have everything we need. If we need to find stuff. The derivative of this would be 12 pi times what? dH dt. Yeah, minus 2 pi h dH dt. Do I need to go find anything? No. Actually, this is nice. It's a new concept. The hemisphere is filling up with water, or leaking water, but it's fine. Can somebody tell me who did this and did all the plugging in, what you got over here on the right? I'll take it. What is it? Negative 6 pi. Do you have a background in negative 6 pi? I see nodding over there. Nodding over here. Nodding? All right. I might have to check that out, but you're in my first hour. Now, what's my label? Area changing over time, right? My measurement unit is what? Meters. So what am I going to label it? Meters squared. And what's my time unit? Water in the tank. Minute. Thank you. Meters squared per minute. How many of you had that one right? Why are so few? Oh! So we're not done yet.
No.
Oh, I want to know the answer to the whole thing. Somebody who did it. What's the answer to the whole thing? You got 3 too? Can I get at least more than 2? 3? 3 calling? Okay. 3 just regular old 3? Okay. Still the same name. Thank you, you guys. Meters squared per second. 3 pi? That's important. 3 pi. Are we better now? Now how many of you had that one right? Okay, much better. This next one is a linear approximation. So remember what that means. It's good to being able to do it is great, but understand what you have. You have some function. You're going to hop on it at a specific point. In this case, it's when x is 4. They did not give me the y. Right? And then what I'm going to do is, why are we chatting? Is there something wrong? Is it still not 3?
Well, it's negative. It's the last one is decreasing. So
But it does say when it's decreasing.
Okay.
So actually, I'm going to stick with their positive 3. Because the decreasing will suck up that negative symbol. Good question, because that's a detail, and I said I was doing this for details, right? So I'm going to honor the 3 pi because of that word decreasing. All right, let's go over here. We're hopping on some function we cannot see, and we are going to hop on a line to approximate what happens just a titch to the right, correct? So I get an equation for the line, and then I plug 4.1 in, and it'll be my estimate. So I need a point. It's 4 comma. They didn't give it to me, but when I plug it in, I get a half, correct? That's that point on that line. I need the slope of that line. The slope is the derivative at that point. So I need to go do f prime off to the side. It's x to the negative 1/2. I'll take its derivative. Negative 3/2, correct? Not a fan of all these negatives here, so I think I'll go negative 1 over 2 square root x cubed. Correct? That would be my derivative. What do I plug into my derivative? Yep, 4 goes in there. So I'm going to take and plug in a 4 to my derivative. It'd be negative 1 over 2 times the square root of 4 cubed. When numbers get big, though, I mean, 4 cubed is easy to do. But if it was like the square root of 16 cubed, do you want to square 16? Or, you know what I mean, or cube it, I mean? You can do them in either order. So I always tell kids, knock it down and then build it up. Do the square root of 4, 2 cubed. Does that make sense? Because if this is a big number, and you don't have a calculator, so watch. What would be the square root of 16 cubed? I wouldn't cube the 16. I would square root the 16, get a 4, and then do what with it? Cube it. Yeah, so knock it down before you build it up. I don't know if you ever taught that, so sometimes I have a gap, I think I told you, because I don't teach Algebra 2 or pre-calc. I mean, not like, I know how to do it, but I don't know how you've been taught stuff. So I would knock it down. So this would be a negative what? 1/16. All right, so now to get the equation for that line, I'm going to use point slope form, right? So I'm going to say y minus that 1/2 is equal to the slope there times x minus 4. When you're doing these, I would move, you're trying to figure out the y value when x is really close to that point of tangency, and we said it's a 4.1. Sometimes kids go, I need my calculator. You don't, because if it's not calculator active, it's usually fairly easy to do. So when I do over here the 4.1 minus 4, I get a 0.1. I think fractions are our friends though. So instead of writing 0.1, I'm going to go with 1/10, especially when I see the answers are all in fraction form. So I have a half minus 160, right guys? And then I need a common denominator. So my half is going to become 80 over, my half is going to become 80 over 160. I'm seeing a 79, is that there? Oh, sweet, I didn't make a mistake. You're my first hour, so it's kind of fun to find my answers. Just like you guys, isn't it fun when you find your answer after doing arithmetic? All right, this last one, let's see what happens. This is a limit question. So in this chapter, if you're asked a limit, what are you pretty much 100% sure they're testing you on? L'Hopital's. I mean, in the grand scheme, when we're done, that's not going to be the case, but L'Hopital's is our new guy, but it's not a multiple choice question, and it says, show all appropriate work. So this would be worth 3 points. What's the first point for? Do them each what? Separately. If you didn't do that, you wouldn't get that point. And if you have the right answer with nothing else, you don't get any points. They call it a bald answer. So that goes to 0, I'm 100% sure. The denominator is going to x squared, 0 squared, plus sine of 3 times x, 3 times 0. You don't need to show any arithmetic here. Just show that you know you're evaluating them separately. Okay? Then you're going to use L'Hopital's rule, so it'd be 1 point for the derivatives and then 1 for the answer. Don't drop your limit. Again, it is an FRQ. Top would be a 7. What's the derivative of sine? Cosine. Yep. On the bottom, I get 2x. What's the derivative of sine? What's wrong with that? The chain rule. Yep, thank you. Boom. And now I replug the 0 in. I'd have 7 minus cosine 0. I don't need to write that out, right? What's cosine 0? 7 minus 1 is 6. On the bottom, I have that 0 plus 3 cosine 0. So I'm seeing a 3. I would get all 3 points for that. Okay? I could make it a 2, and I would love it if you did, but you don't have to. How'd you do on those? I took the harder ones. So now you're going to actually go all the way back to the beginning of the chapter. And you're going to review. Okay? This guy's not due till Tuesday. When? There's another one coming at you tomorrow. It's a little longer, so you might want to have this one a good chunk done by tomorrow. The key's posted. This is the shorter of the two. If we work on it well for the time we have in here, I will not move on Friday. I kind of want to. All right. So, right now, what should we all be doing? Number one, dig in and start it. All right, is calculator active? One more. Oh, I'm going to stop recording.